Hello, and welcome to G Fun Facts Online. Today, we're venturing deep into the cosmos, where a fiery, geological drama is playing out across thousands of distant worlds. Forget what you think you know about volcanoes being just destructive forces. On a galactic scale, they might be the single most important architects of life. We're talking about exoplanets, and how molten rock and spewing gas could be the key to finding our cosmic neighbors. So why all the fuss about gas? Well, an atmosphere is like a planet's life support system. It keeps the climate stable, shields the surface from deadly radiation, and holds all the chemical ingredients you need for life to get started. On Earth, our atmosphere was forged in fire through a process called volcanic outgassing. That's when gases trapped deep inside the planet's molten mantle are blasted out onto the surface. Now, astronomers believe this same process is a lifeline for exoplanets. Many of these worlds, especially the ones called sub-Neptunes, start with a thick, fluffy atmosphere of hydrogen and helium. But if they're too close to their star, that primordial atmosphere gets stripped away by intense radiation. It's like having your blanket ripped off on a cold night. But this is where the planet can save itself. Hydrogen and other gases can get absorbed into the planet's molten interior, its magma mantle. Then, through volcanic eruptions, these gases are slowly released back out, creating a brand new, secondary atmosphere. It's a planetary rescue mission powered by geology. Here on Earth, our volcanoes are tied to plate tectonics, the constant movement and recycling of our planet's crust. This process is brilliant for regulating our climate over millions of years. For a long time, scientists thought no plate tectonics, no life. It was a potential deal breaker for many exoplanets, which we think have what's called a stagnant lid crust, basically one solid, unbroken shell. But new research is flipping that idea on its head. It turns out, even on these stagnant lid worlds, volcanoes could still be powerful enough to create a stable, life-friendly climate. Eruptions can bring enough fresh rock to the surface which, when combined with the outgassing from a hot young planet, can kickstart a carbon cycle that keeps temperatures stable for billions of years. That's more than enough time for life to get a foothold. It all comes down to the planet's internal heat. More heat means more volcanoes for longer, extending that precious window of habitability. Now let's talk about the heavyweights of the rocky planet world. Super-Earths. These are planets up to about 5 times the mass of our own, and they are incredibly common. It turns out, bigger might actually be better when it comes to hosting life. Because of their greater mass and hotter interiors, super-Earths are expected to have way more volcanic activity, and for much longer. This means they are constantly pumping out essential gases, building and maintaining their atmospheres over vast timescales. But there's a bonus prize. The same internal heat engine that powers volcanoes also generates a planet's magnetic field. A stronger, longer-lasting magnetic field acts like a planetary force field, deflecting harmful cosmic radiation and making the surface a much safer place for life to exist. This all sounds like great theory, but where's the proof? Enter the James Webb Space Telescope. The JWST is an absolute game-changer, letting us actually peek into the atmospheres of these distant worlds. And it's already finding some incredible clues. Take the exoplanet 55 Cancri E. This is a scorching hot rocky world, so close to its star that everyone thought its atmosphere would have been blasted away ages ago. But JWST detected a substantial atmosphere, likely made of carbon dioxide or carbon monoxide. The only way it could still be there is if it's being constantly replenished from below. The leading theory? A global lava ocean with raging supervolcanoes. Another world, GJ1132b, seems to have lost its first atmosphere but grown a second one, all thanks to volcanism. The JWST is giving us front-row seats to watch planets rebuild themselves. So when Webb points its mirror at a planet, what is it actually looking for? It's all about chemical fingerprints. For example, Huge volcanic eruptions can blast sulfur dioxide high into the atmosphere, creating a haze of sulfate aerosols that Webb can detect. Sometimes, the most interesting clue is what's not there. The telescope looked at a planet called TRAPPIST-1c and found it was missing the thick carbon dioxide atmosphere everyone expected. One exciting interpretation is that the planet is geologically active, with its own carbon cycle pulling that CO2 out of the air just like on Earth. And what about oxygen, the holy grail of biosignatures? Well, detecting oxygen alongside volcanic gases like sulfur could actually strengthen the case for life. Why? Because those volcanic gases would normally destroy oxygen. So if both are present, it means something is producing oxygen at a truly massive rate, something like a global biosphere. The same goes for methane. Volcanoes can make methane, but they also pump out carbon monoxide. Life, on the other hand, tends to produce methane while consuming carbon monoxide. So an atmosphere rich in methane but low in carbon monoxide, that could be a very compelling sign of biology at work. So the picture is becoming clearer. The fiery, chaotic forces we see in volcanoes on Earth might be a fundamental ingredient for creating habitable worlds across the galaxy. It's a profound shift in thinking. The universe isn't just full of dead rocks. It's filled with dynamic, evolving planets, powered by their own internal heat engines. And these geological engines might be what sparks and sustains life. With every new observation from the JWST, we're getting closer to solving this incredible cosmic puzzle. The volcanoes of distant worlds might just be lighting the way to the biggest discovery in human history. Thanks for listening to G Fun Facts Online.